Hello again, Francisco. I'm looking here now at question 4 from page 2 of your exam. There we go. Can see it better now. Okay, so you started off well here because you did factor the original function and you factored it correctly on top. Unfortunately, on the bottom you have it factored correctly as well, right? 2 times x squared minus 1, and then x squared minus 1 factors is a difference of squares, okay? So that's a good start right there, is to show your work by factoring. All right, so for vertical asymptotes, you have a vertical asymptote here, and I don't know what you mean by that. It says x minus 1. A vertical asymptote has an equation, and in this case, the whole is at x equals 1. We'll talk about that in a minute. The vertical asymptote is at x equals minus 1. That's the equation of a line at x equals minus 1, where the graph cannot cross that line, okay? So it has to be an equation of a line in order for it to be a vertical asymptote. Now, for the whole, you're right, and the whole, when we do this, the whole is not an interval. I see what you're trying to say here. I think that is an ordered pair, maybe. The whole exists at x equals 1, because this and this can cancel each other out. They can divide out. And so what we call that is a removable discontinuity. And so that's just going to represent a section of the graph where there's a hole in the graph, which we denote like that when we're graphing it right at that point. And so at x equals 1, we would put an empty circle to show that at that point there's a hole in the graph. And so what we write is hole at x equals 1, okay? Now, for your horizontal asymptote is y equals 1/2, but there's nowhere in your work here that you're indicating that that's what you're finding or why you're just using these values. Generally what we do is we go through and we divide the whole equation, every term in the equation, by the highest exponent of x in the equation. So in this case it's x squared. And if we do that, then that would show us, we would have like x squared over x squared, 3x over x squared, minus 4 over x squared, and so on. When we let x approach 0, then we can show why we end up with a horizontal asymptote, and we would say the horizontal asymptote is y equals 1/2. There's nothing here to indicate, and I wrote that in my notes, that you're trying to show that that's a horizontal asymptote. There's no label to say the horizontal asymptote is y equals 1/2, and there's no work shown to show how you arrive at just these terms left out of this equation. And so you need to be more specific in the work that you're showing in your work when you hand it in for marks, okay?